Look at your phone. The screen is made of millions of tiny dots. Pixels. Each one has a color. Now picture this. You're looking at a photo of your friend's face. Skin. Eyes. Smile. But one pixel, right in the middle of their cheek, is dead. Stuck on black. The phone can't display anything there. You'd still know what color that pixel should be, right? It's surrounded by skin tones on every side. You don't need the broken pixel to tell you. The pixels around it tell you everything. That instinct. I know what it should be, even though I can't see it. That's a limit. One of the most important ideas in all of math. Hiding inside something you do without thinking. Today, we're going to look at what a limit really is. Because once you see it, half of calculus stops feeling like magic. Quick word before we go deeper. What's a function? A function is just a rule. You give it a number. It gives you back a different number. Like a vending machine. You punch in a code. You get out a snack. Same code. Same snack. Every time. That's a function. Now back to the pixel. Think of the photo as a function. You give it a location on the screen. It gives you back a color. Most of the time, it just works. But at that one broken spot, the function has nothing to give. It's undefined right there. And yet, the surroundings still tell you what should be there. The color the photo is heading toward near that pixel. That's the limit. Let me say the key idea slowly. A limit doesn't care what happens at the point. It only cares what happens near the point. Now let me show you the same trick with real numbers. Picture this. You're walking toward a wall 1 meter away. But you have a strange rule. Every step you take, you cover exactly half the remaining distance. Step 1. Half a meter. You're at the halfway mark. Step 2. A quarter of a meter. You're 3/4 of the way. Step 3. An eighth. You're at 7/8. Step 4. A 16th. You're at 15/16. Watch the total. 1/2. 3/4. 7/8. 15/16. 31/32. The numbers are creeping up to 1. Never quite touching it. But you can get as close to 1 as you want. Just take more steps. So we say, the limit of your total distance is 1 meter. The wall. You never actually arrive. But the wall is what you're heading toward. And in math, that's enough. That's it. That's a limit. The value something is heading toward. Even if it never actually arrives. You couldn't compute where you are after infinity steps. Infinity isn't a number you can plug in. The math breaks. But the limit doesn't need infinity. It just needs to see that the numbers are clearly aimed at 1. Now, there's one important rule. A limit only exists when both sides agree. Picture a hiking trail. You're walking along. The ground is steady at 100 meters of elevation. Then you reach a cliff. Right past the edge, the ground drops to 20 meters. What's the elevation at the cliff edge? From the left side, you're heading toward 100. From the right side, you're heading toward 20. Two different numbers. They don't agree. So we say, the limit doesn't exist at that point. There's no single elevation the trail is heading to. It depends on which side you came from. For a limit to exist, both sides have to be heading to the same place. Left and right have to meet up. Back to our pixel. The reason the pixel trick worked is that all the surrounding pixels, top, bottom, left, right, agreed. They were all the same skin tone. If half had been black and half had been pink, no limit. You wouldn't know what color the broken pixel should be. Which brings me to the big point. Why should you care about any of this? Because every single idea in calculus is built on this one trick. A derivative. That's the name for finding how fast something is changing at a single instant. Your car's exact speed at one moment. How steep a hill is at one point. Finding that use is a limit. You can't measure speed at an instant. The math breaks. But you can shrink the time window smaller and smaller and watch where the answer is heading. That heading toward value is the derivative. And it's a limit. If you want the full story on derivatives, I made a whole video on it. Links in the description. Integrals. Finding the total area under a curve. Also use limits. Picture slicing a pizza into thinner and thinner strips. Add up the size of each strip. That's your guess at the total. Make the strips thinner. The answer creeps toward the true area. That creeping toward. It's a limit. There's one more idea limits give us. It has a fancy name. Continuity. Don't be scared by it. It means something simple. Continuous just means it flows without breaks. Think of a roller coaster track. A smooth ride from start to finish. That's continuous. A gap in the track? You're flying off into the air. That's a discontinuity. Bad day. The math version says, a function is continuous at a point when the limit equals the function's actual value there. The function smoothly arrives at exactly where it was heading. Most things you can draw with one stroke of a pen, without lifting it. Those are continuous everywhere. That's continuity. Okay, let's pull it all together. A limit is the value something is heading toward, not where it equals, where it approaches. It doesn't care what happens at the point. It cares what happens near the point. For a limit to exist, both sides, left and right, have to agree. And this one idea is the foundation under all of calculus. Derivatives are limits. Integrals are limits. Continuity is a limit being well behaved. That's the whole story. If someone ever shows you a scary epsilon-delta definition of a limit and tries to convince you it's complicated, just remember the broken pixel. You knew what color it should be. That's a limit. Everything else is just fancy symbols. In the next video, I want to talk about integrals. The other side of calculus. Where derivatives ask, how steep? Integrals ask, how much? And the wild part. They're secretly the same idea. Running in opposite directions. That's coming next. If this was useful, the best thing you can do is hit subscribe. Honestly. The channel only grows because people who got something out of a video click that button. So if I earned it, please tap subscribe. Thanks for watching. See you in the next one.